Thank you, John. Yes, indeed, when we first put together the program, this slot was to have been delivered by Simon Hodson, who's the current executive director of CODATA. He had to withdraw at short notice, but he expressed very much the interest in what we're doing as a community, the structural science community, and the leadership role that the IUCR has shown through development of the CIF standard and the encouragement of initiatives such as this one. So I'll say a few words of introduction about CODATA. As John mentioned, it's a formal committee of ICSU, which at the time of its foundation was the International Council of Scientific Unions. ICSU is now the International Council for Science, but retains the same acronym. The Committee on Data for Science and Technology was founded in 1966 as a full scientific committee, with a mission that's been restated recently to strengthen international science for the benefit of society by promoting improved scientific and technical data management and use. In recent years, that seems to have found expression in a lot of large meetings about societal benefits of scientific data. A lot of the energy of CODATA in recent years has been on large-scale global data sets, both in terms of earth sciences, climate monitoring, health sciences, and so on. So its focus has drifted away a little bit from the benchtop scale science that was its primary impetus when it was founded over 50 years ago. Nonetheless, its broader remit states that it's concerned with all types of quantitative data, from experimental measurements or observations, and its starting point was the physical, biological, geological, and astronomical sciences. And from the early days, particular emphasis was given to data management problems common to different scientific disciplines. So it always had this very interdisciplinary thrust. It was an international organization by statute, and so it's had a long and I think generally very excellent record as being the center point of those two foci, of bridging the requirements between different scientific disciplines and doing that worldwide. And fitting in with this, the general objectives include the improvement of quality and accessibility of data. So during the time that I served as IUCR representative, even when the discussion focused on medical data records, on climate science, and so on, the crystallographers, rather than feeling out of it, could always stand up and say, "That's all very well, but don't be overwhelmed by the size of these data sets. Assess their quality, their credibility, their validity. Do your statistics properly." So that's something which benchtop science, done very carefully, still can contribute to the broader, rather more fuzzy world of psychological data, medical research, and so on. CODATA is headquartered in Paris, actually sharing premises with ICSU headquarters at the moment. Its formal members are national members who are individual scientific academies or groups or consortia that have a strong interest and representation in data science practice in that country. International scientific unions are members by right because of its heritage from ICSU. There are also co-opted organizations and supporting organizations which can bring particular expertise from different areas. A list of its present officers, that suggests quite a Western Hemisphere-centric composition, but that's accidental. Recent presidents have come from the Far East, from India, and so forth. Current executive director, Simon, who we had hoped would give this talk, is already known to many of you because in his former incarnation, he headed the JISC research data management set of initiatives for some years. CODATA goes about its practical work in a couple of ways. It has a number of task groups which must be endorsed by the General Assembly of CODATA. But these task groups grow spontaneously from initiatives arising from the member groups. And so it's perfectly possible for union member, for example, to set and train a task group to try to achieve some particular purpose. The nice thing about that is a small amount of funding is available, so it's a nice opportunity. The drawback from our point of view, I never was able to initiate a task group, but I did serve on a number. The drawback is the task group must be interdisciplinary, so you need to find a group of collaborating members who share the same concerns and objectives. But it might well be a useful benchmark or a useful position from which to develop specific projects. But CODATA also from time to time does commission working groups to look at specific projects. And Brian mentioned a recent one. The title of the project was The Description of Nanomaterials. IUCR had an involvement in that, and I'll say a little bit more in a moment. The Premier Prize of CODATA is awarded on a 2-yearly cycle to scientists who've shown outstanding achievements in the world of scientific and technical data. And we were honoured last year that the recipient was Sid Hall for the work he had done in the Starfile information organization framework. That is the parent structure for CIF, which is so central to crystallographic information. And it was also very appropriate, I think, that was an award made during the International Year of Crystallography. It reflected very much, again, the leadership that IUCR is seen to have shown in that field. As John mentioned, I served as official representative to CODATA for a 12-year period. John himself has taken over in 2012 and has already had lots of active involvement with CODATA meetings and projects. So a little bit more about the working group that I mentioned on the description of nanomaterials. This is a way in which CODATA seeks to generate particular synergies between disparate groups. This was convened first in 2012 under the auspices of CODATA and the Versailles Project on Advanced Materials and Standards. And the chair initially was John Rumble, who was formerly head of crystallographic and other physical science databases at NIST. And there are now a couple of additional co-chairs from the VAMAS side. In its 3-year history, it's run a number of workshops, and the inaugural and follow-up one in Paris. The IUCR had active involvement there. Reinhard Nader in the launch workshop, and Daniel Chatinier, who took on carried on the torch in the subsequent one. And the deliverable at the end of this 3-year period has been the publication earlier this year of a uniform description system for materials on the nanoscale. So just to illustrate that our input, the IUCR's input collectively, was summarized at a poster we delivered at the ACA meeting in 2014. It represents some synopsis of the various presentations that Reinhard and Daniel gave at these meetings. And there are extracts from some of their presentations. And you'll see that they had a focus on the types of crystallographic techniques you might use, crystallographic and related techniques that you might use to characterize the crystalline structure of nanomaterials. But this was done in the framework of a much greater remit. So the idea of this uniform description system was that it could be used not just by structural scientists, but by material scientists, by applied chemists and physicists, by people working in energy technology, any applied field that might make use of nanomaterials. And the overall objective was to get essentially a framework to describe concepts referring back to the nanoscale. So I imagine you can't see in detail the crystallographic crystal structure input. You can look at the slides on the web later. But you'll see essentially that these are core terms that were simply extracted from the core CIF dictionary and go across very nicely in synoptic descriptions of the types of information that, at base, you would want in describing a nanostructure of some crystalline material. So at this level of interoperability between different unions, different disciplines, the volume of metadata descriptors that needs to be contributed by a particular agent, such as the IUCR, need not be very large. But nonetheless, it's seen as crucial because this is the, so to speak, the official view of that discipline, of the type of information that would be required in the broader framework. And that's the type of level at which CODATA can prove effective. I'll just mention briefly a few other organizations that, to some extent, share the limelight in this field of generating and correlating interdisciplinary interest in scientific information through metadata characterization. So another organization that we've been closely connected with at the IUCR is ICSTI, the International Council for Scientific and Technical Information. In some ways, that's a sister organization to CODATA. It's structured slightly differently. It's an affiliate rather than a direct committee of ICSU. And its mission to facilitate cooperation among stakeholders engaged in the scientific communication process has traditionally led to a focus on scientific publication and collection of sort of patent information and, to some extent, curated databases. But over the last few years, its interests have come to be more convergent with the whole information flow, including data, that CODATA has had an interest in. So there have been examples of joint task groups like the CODATA and ICSTI task group on data citation standards and practices that Susanna mentioned as one of the things that feed into the CCDC way of deciding to cite data sets. And over the last few years, there have been a number of workshops or conferences convened by ICSTI that we've participated in and that have considerable relevance to the whole business of data management. And you'll remember from John's introductory presentation yesterday that they also provide a periodic publication or an occasional publication called ICSTI Insights. And Tom Terwilliger and I contributed a set of contributions outlining the relationship between data and publication in such things as the living publication, the living PDB. Another organization that's been mentioned a few times today is the Research Data Alliance. This is actually an organization launched in 2013 that the IUCR centrally hasn't engaged with very closely. But many of the people in the room here have already explained to us the involvement in individual task groups. And I think we'd like to engage with them a little bit more closely and see how we can contribute directly to some of their initiatives. The core group founding this alliance were government-level institutions. The European Commission was one of the founding partners. The US was represented through the NSF and NIST, and the Australian Government Department of Innovation was one of the founder members. And since its launch, it's rapidly diversified, has a large number of other agencies and associate members, and reckoning on an individual membership basis, it now has over 3,000 associated individuals from over 100 countries. It does have a large number of plenary meetings. It seems to meet at the moment on a 6-monthly cycle. And these, by the look of them, seem like they should be very stimulating meetings to attend because they collect together in terms of birds of feather meetings and so on, the ongoing work of their various projects. So the RDA seems to have this project-oriented methodology, identify a problem, and tackle the way to solve it. And in a fast-moving area, that seems to be something that has a great deal of potential. On the other hand, in a fast-moving area with lots of people keen to try chipping away at some part of the problem, there's the question of how you actually see how your contribution fits into the whole. And so I think, again, going back to organizations like CODATA, the long-term role there is to coordinate all these individual, very energetic projects and make sure that there's some coherence and consistency in the understanding of data science as it evolves. Another organization I'd like to mention is the Digital Curation Center, which is a national center of expertise that was launched with funding and support from JISC. Among its founder members were UCOM, the UK Libraries Network, and STFC was an early founder member and inspiration behind it. And it initially it developed curation tools because the whole idea of digital archiving is novel. Nowadays, its focus is on passing on that expertise to build capacity, capability, and skills. Its main focus is the UK's higher education research community, but its activities are all public, and it provides a lot of useful input into the wider world. And one particular initiative that started a few years ago was to bring together a catalogue of specific disciplinary metadata schemes. And this is now an enterprise or an effort that's been taken up by the RDA in collaboration with the Digital Curation Centre. And there's now a GitHub site in which different communities can contribute to the specific metadata schemas or catalogues that are relevant to their expertise, to their area of interest. So for instance, if I go back to the DCC site and you look into, say, the physical science portion of this catalogue, they've already identified CIF, the crystallographic information framework. The CSMD is developed by the STFC, is there, it's listed nicely. And PDBX, which is the protein data banks management of the MMCIF effort, also gets a separate listing. And if you go, now this is just a different view on the RDA website, this is the type of information that is catalogued for each of those different metadata schemes. Now, so something like this, which was initially a central effort of the DCC, moving out to an RDA distributed project, encourages really contributions from the different communities. And sort of in that context, something that I thought would be nice to do for this workshop was to put together on the IUCR website a nascent catalogue of metadata resources for crystallography. And it's a website, I'll talk a little bit more about it in the practical session, but it's open to any member of the community to contribute specific information about individual ontologies within crystallography. And these in turn can be fed into the RDA effort. The DCC also records more generic metadata systems. We've had a number of these mentioned during the course of presentations earlier today and on occasion yesterday. And again, in the practical session, I'll have a look at some of the issues between meshing these generic metadata systems with the rather more detailed systems that we need in order to maximize the scientific information that we get, going back to yesterday's discussion, from the raw images that we're collecting. So there is at the moment this spectrum of granularity between metadata systems, the very coarsely granulated generic systems like Dublin Core, the very finely granulated systems of the CIF Core dictionaries or the Nexus applications. And if you want to have interoperability between disciplines and applications, what's the best way to mesh those different granularities? So you would expect that an approach to this would be to set up concordances where you could, say, map the disciplinary metadata catalogues onto the generic schema. So this table shows a way that you might approach that. If you look at the generic metadata schemas like Dublin Core, what is their raison d'etre? Largely, it's at the level of cataloging, classifying, discovery, location of resources in the most general sense. And as such, it's immensely valuable for digital librarians and archivists, or repository managers, or even for funders where you're funding a range of projects across different disciplines. You have common things that you want to find wherever those are stored. But because it's general, its level of granularity is micro. There are, in the original Dublin core schema, only 15 terms, has diversified somewhat, but as a lowest common denominator, it retains that coarse granularity. On the other hand, because it's something which binds together all these disciplines, it has to be pretty static. It's a standard that you can rely on, so that when you add a new repository, it follows the same schema as the initial repositories in your database set up 15, 20 years ago. If you have a very small set of terms and a growing number of applications, then the semantics of those terms is necessarily rather fluid. So in a granular system, you might have a number of different terms that will map or can be mapped onto one of the small set of terms available to you in Dublin core. Again, later today, if time permits, I'll show some examples of that. And you contrast that with something like CIF. The purpose is more geared, I think, towards the scientific value of the information, the reproducibility of the experiment, the provenance in terms of trust and validation and reliability, and that's of use to practicing scientists, to software developers who are developing new algorithms, to laboratory management developers, and so on. I characterize its granularity as micro, and in parallel with that, the scale of the schemas is much larger. So the PDBX dictionary, for instance, has nearly 5,000 discrete terms identifying different components of data. But in contrast, each term has a fairly precise meaning. So just to show this, this problem of many-to-one mapping, if you look at one of the Dublin core terms, like creator, it's defined as an entity primarily responsible for making the resource. Those are very general terms. So what is the resource? If you imagine this as being a schematic of crystallographic information from experiment through to analysis and publication and onward dissemination, you can extract information in CIF format at any step along this pipeline. And if you did that, what would be the equivalent entity or the equivalent term you would look that would map onto DC creator? It could be the audit author, even at the time of experiment, but it could be a computing system, a data collection package, or cell refinement package if you're setting things up on the goniometer. By the time of publication, it's fairly direct. It's the pubble author. By the time you're disseminating stuff from the database, it could be pubble author, so the author of the original publication that you're referring to in the database. But the structure may never have been published, so maybe an internal identifier of the CSD is an appropriate mapping to DC creator. So it's very often straightforward to envisage a mapping between metadata schemas, but in the grand term, because of this disjunction in granularity, there may be multiple many-to-one mappings. And so it may well be that there's a need for another layer. I've called it here meta-metadata, or it might be called middleware. And we've seen examples of schemas such as this, like the efforts at ESRF that were mentioned yesterday, like the ICAT catalog that Brian spoke of earlier today, that this middle layer is bridging the gap between very coarse generic metadata, very specific crystallographic metadata. This has another role to play. It's collecting information from multiple disciplines. It's percolating it out to a completely different range of disciplines, accessing it through this level. And one of the things that this working group might give some attention to in the next the next period of its work, is have we got enough in the way of middleware layers? Do we need to put some effort into specifying what's an appropriate way to bridge the gap between CIF and the wider world? Thank you for your attention.
Thank you very much, Brian. Questions to Brian? The different organisations coming into them afresh, as it were, as a new boy, myself. CODATA, of course, is wedded to these global data projects, climate change and so on. And I think it's worth mentioning the World Data System, which is based in Japan for ensuring the capturing of climate change data. And so within that and similar projects, CODATA has this luxurious position, if I may label it that, of automatically assuming that government funding, different governments will always be available. So it's able to champion, without any look over the shoulder, open data. Now, the Research Data Alliance will be interesting as we get involved with it, but so far it seemed to me to be particularly focused on a forum for data managers and data specialists, but clearly also, secondly, fills a slight vacuum that CODATA has vacated. But if you think about the percentage of research that's funded by the governments, you might find ways of estimating that, and my estimates are around 20%. Therefore, open data as a luxury isn't a guaranteed. So the subscribers to publication and to databases paying for the service is a very interesting topic and a very important topic and needs championing because, for example, in my own work, approximately 80% of the work that I do is without a government research sponsor. And therefore, 80%. So I rely heavily on subscribers to make it feasible for me to communicate my research, so far mainly publication. And the data archiving and the responsibility of the University of Manchester is being executed, but it requires budget. And so it's not always the case that the research sponsor, Higher Education Funding Council for England, provides necessarily that, nor the parents of the students who pay the fees, which is now in the UK, the American model. So I think there is some very interesting aspects to do with these organisations. What are their implicit assumptions in this generic overview of open data and open literature? And it is not as simple, in my opinion, as a researcher in the trenches, as CODATA would like to make out. And I'll be very interested to see what the Research Data Alliance says on these different things. Now, I've listened through WebStream to the plenary type events that they coordinate, and that does include pinning to the mast of open data. And I really don't think it is as simple as that. Science has, I think last year, run an article about the possibility of an iTunes model for downloading data. And why not? Anyway, so I think there are some wider things here when you look at these organisations and scrutinise carefully their policies and postures.
I think I'd agree with that. I've little more to say, other than that the IUCR, of course, has experience of this, although not directly responsible, the IUCR is very supportive of the databases that exist under different funding models. So PDB is publicly funded database. The Cambridge Structural Database at the moment flourishes through a subscription model. IUCR journals themselves have traditionally been subscription journals, but we now have 2 fully open access titles, and all the journal titles support open access as a hybrid option. It's quite a complex ecosystem of feeding, nurturing, and supporting all the things that scientific endeavour has to repay back to society. And as John says, it's not as simple as saying, here's a completely new model that can revolutionarily overthrow everything that's gone before.
And in particular, IUCN Journals achieves open access for readers through 2 particular titles, and open access for authors through the remaining titles. And the ICSU working group that looked at open access and metrics, which I took part in, wanted to emphasize the need for open access for authors and open access for readers. And that is what is open access. Whereas predominantly when people talk about open access, they mean open access for readers, but that is not as simple as that. Vladek.
Talking so much, but in US, 96, 97% of the funding in academia is coming from government. One or the other way from government. It can be done through various organizations, but it's coming from taxpayer money. The other thing about journals, that now everybody who has NIH grant has to deposit, or journal has to deposit for him, every paper to PubMed Central. And basically, if you publish something which is 3 months old, and it's not in PubMed Central, it may not be available for user for 1 year. But if it's not in PubMed Central, your money are stopped. Yes.
So
we are in US in little different situation.
Yeah.
And that is why I think the analyses of what is the most innovative research and whether it is done through government funding, those type of analyses are particularly interesting. And I apply, for example, what I call the Albert Einstein test, who had 0 government funding. No buts. And was able to do the most innovative science. Yeah. But he relied on subscribers making a vehicle to communicate the research. There are formal analyses about what and who is funding the most innovative work. So when I have something that is declared in a grant proposal, international standard, sorry old chap, too low down on the list, I don't give up on the questions I pose. I try and find a way of doing them. It takes longer, and I will have to do a much more curtailed version of the work. But it's so important to preserve the commitment to doing the innovative work.
Yes, you are absolutely right.
Shall we break for coffee on that happy moment?
What was Einstein's age factor?
And perhaps if we return in 15 minutes. Thank you very much.
What was his age factor? Yes, you're absolutely right.